Tim! All right, I'm constantly yelling. Tim, what can you tell me about region 1? What do you see?
Looks like the radius is equal.
Okay, so what do you know about the circles? Good. It's a good start. What else you got for me?
The radius is equal to there.
Good. Keep going. You're killing it.
The arc is also
Why? Yes, but why?
the radius of the arc is
Who's talking? You know those angles are equal. Okay, good. So, bottom line, those arcs are equal.
yes.
Okay, good. Kathy, you have region 2. What do you see?
That.
Wait, hold on one second. Sorry to interrupt. You think for a second. I gotta ask Tim another question. Hey, Tim, when you said those arcs were equal, were you talking about the arc measure or the arc length? Correct.
I was talking about
The lengths are the same, right? The measure is the same also? Yes, so same. Okay, beautiful. Catherine, back to you.
The AD and BC have the same measure?
How big would that measure be?
89?
Good. Okay, I like it so far. What else you got?
That's it, I don't know.
Are they the same length?
No?
Is that fairly obvious?
Yes?
Okay, so it's not the same distance from B to C as it is from A to D. Does everybody agree? Okay. What can you tell me about the two circles, Kevin?
Do they both have a center mark?
Good. Are they congruent though?
No.
Tim's circles were congruent. Are yours congruent?
No.
Because they don't have the same radius, right? Okay. By the way, those are called concentric circles. Doesn't come up very often, but when they share a common center, they're called concentric. Okay. Beautiful. Let's see. Aisha, what do you see in region 3? Okay, so how big are those other angles?
70.
And?
And the other one is 110.
Good.
70.
Good. What else you got?
The arc measuring goes 110.
What are you talking? Orange or green?
Green.
Green. The green is 110.
And then the orange is 70.
Okay. And the two greens are the same.
Yes.
Okay. And the two oranges are the same.
Yeah.
Beautiful. Any problems? Okay. So notice in 1 and 3 the arcs are the same measure. In region 2 the arcs have the same measure. However, in region 2 those arcs don't have the same length. Is that fairly obvious? Good, then we're not going to beat a dead horse. We'll move on to something more exciting. Okay, so I've got a circle. I've got two chords that are the same length. Okay, you can see if I grab this one and put it over the other one, they are the same length. So I slap them both in the circle. There's one. Here's the other. And label some points here. We'll call this AB. Call this CD, and we'll make this center Q. And we know that AB is congruent to CD. Whoops. What else do you think might be true? Lucas.
Like the inside, I guess, of the chord.
Be more specific.
To the left of AB would be equal to the right of C. Like,
Here, catch. Come up and draw what you're talking about. I don't want to guess and be wrong.
so like this area is equal to that area.
Oh, now you're talking areas.
Interesting. So you're saying this is equal to this.
Agree or disagree? Can you find the area of that thing?
Probably.
Yeah, eventually you will. Good, thank you, you can sit down. What else do you notice? Help me.
CD is the circumference,
C,
or diameter.
we don't necessarily know that. It could be. If I connect C and B, it might go through Q, but it doesn't necessarily have to. I could take that chord AB and swing it around the circle and put it in a different location where it doesn't necessarily match up.
If you make a chord with A, C, and B, D, they would be equal.
If you make a chord with A, C, and B, D, so you're saying this.
Connect A, C, and then connect B to D.
Oh. You think so, huh?
I think so.
That is equal to this?
Yes.
Agree or disagree? I think in this case, if I pick up this green chord and drag it over here, I think they're going to match exactly. But I think that's a fluke.
Okay.
Okay. Again, if I take this and rotate it over here, this opening would be much bigger than that opening. So it just happens to be a weird situation the way I set up the problem.
Okay.
All right. Other ideas?
Getting all the tricky things and missing the obvious one. What can you tell me about arcs A, B, and C, D? They're equal. Is that so obvious you missed it? Yeah.
So we get a little theorem here that says in a circle, congruent chords, congruent arcs.
Lucas, we're going to come back to your idea later on when we start talking about the area, because we'll be finding the area of these chunks of regions inside a circle, but for now we're just going to postpone that. Okay. Notice, two arrowheads means it's reversible. If the arcs are congruent, the chords are congruent. If the chords are congruent, the arcs are congruent.
Okay, that's good. Let's try something different here. Let's get rid of this guy. And let's put a Q back here. If I draw in this segment, ooh, that's way off. All right, let me see if I can fix this. Okay, that segment I just drew, or that line, if you prefer it to be a line, it doesn't matter. I drew that with two things in mind. The first thing is that it passes through the center of the circle, which you can clearly see. And the second thing is it passes through the midpoint of that chord. Okay, so in other words, this and this, let's call this M. AM and MB are congruent.
If that is true, what also appears to be true? What else do you notice from that picture? Lucy?
They're perpendicular.
Beautiful. Which makes green the perpendicular bisector of that chord. Now that's not a fluke. That one works all the time. No matter what chord I draw in, if I take the perpendicular bisector of it, it's going to pass through the center of the circle.
Okay, so if I take this little guy over here, and I draw the perpendicular bisector, let me put that on the circle, right there, and I draw the perpendicular bisector of that segment, it will pass through the center. Whoa, I missed again. It passes through the center of the circle.
Okay?
Any problems? Is all this stuff pretty obvious when you see the picture? Okay, let's try something that's not so obvious. Let's say this chord is 20 centimeters long. And it's 7 centimeters from the center of the circle. So notice, if the chord gets bigger, it moves closer to the center. If it gets smaller, it moves closer to the circle. If that's the case, then I would like to know what's the circumference of the circle. And as a bonus question, what's the measure of arc AB? Understand the questions? Any problems? Well, obviously there's problems, but solve them. Work with your group to try and find answers to those problems.
I was like,
It's the radius.
what is
The radius of the Because AB divided by 2, then that's 10 and 10, that's two sides. It's like A to M and M to
Oh wait, I know.
We lose value of this side up here.
7 is M wait. Is 7
That's frequently called the distance from the center of the circle.
It has to be mean. Yeah, because
Don't touch the screen.
How did you find that website? From M
like,
Are you saying you know what number is this? Oh yeah, you're right.
Wait, I have a question. Couldn't we do, make it one here, make it like a triangle, and since it's a right triangle, do the Pythagorean from Q to B, and do Pythagorean theorem to find that, is that's the radius, right? We're gonna do Q to A or B, whatever one, do Q. And then we're doing Pythagorean theorem to find Q to A.
See?
What's this? C squared equals 139. C equals 12.2.
Come on, buddy.
so the circumference,
So 12.2 times 2.
It was 24. Yeah, so
yes, it's 38.
Because that's just the radius.
so it's 76.65. So you have to multiply the radius by 2 and then multiply that by pi. It's 76.65.
Yeah.
Guys, I just saved this there. I literally just saved this there. 76.65.
Okay, I did the radius instead of
Okay, and then the arc of AB.
Yes!
When I get to 10.
Oh, you got 22.
Yes!
AB, and there's two congruent, where does it, then there's two congruent sides. So now we just have to find AB. Well, I think we have to connect A to Q and B to Q and find the angle.
The central angle over 360.
Like, are we doing the 180? Or are we doing that and that?
Wait, I know how to do this. Wait, because this is how you set it up to find the central angle. 'Cause usually central angle will be right here. So now do we just
Oh yeah, 2 pi r is circum.
Well, you got anything over there?
now to find x in this case we have to cross multiply put that over 1. That's sort of the one
So do it. I didn't say you're right, I just said do it. Doctor?
we did connected A to A and then and then we have the radius and we multiply that by 2 and then times pi to get
Alright, Professor. Now what about RKB? Oh yeah, and that's where the fun is. Come on now. Any progress, chicas?
Are we measuring the distance from A to B?
Which end?
where in one.
If M, if this little bucket was over here, it would work.
This is the radius. Yeah. So it's 7. 10 squared, 10 squared.
You got
We'll just find the chord is 20. It's like, wait, no, here, this is congruent chord equals congruent arc. Like, these two are congruent, like, if these two are congruent, then these two are congruent. That's what I think, I don't know.
Isn't it just?
Yeah. We can find the length, but we can't find the
Should we find the length?
Wait, no, I set it up right. How I had, I know, this is how you find arc length. X over 3, but this right here, X is the central angle. So if you solve for X, X is in the central angle.
Because this isn't.
No, it's not.
Okay, hold on, quick question, sorry to interrupt. The bonus question, am I asking you for an arc measure or an arc length?
Measure.
Measure, so your answer should be in degrees or centimeters? Degrees, correct. Carry on.
I'm just gonna try this and see what I get.
Yeah, it's in the middle. Yeah, that's what. Yeah, I know.
Okay, that's
No,
definitely not
wait a
it.
minute. What is this angle right there? Find the arc maker.
But we need to know the.
From the center. Yeah, we just trying to measure the same.
Maybe find the arc length. Plug in the
What I was thinking is we also did like the 70 over 360 times circumference. So what if we do x over 360 times circumference? I don't know. I'm trying to do it.
Well, you're talking about arc lengths, we're not looking for arc lengths, we're looking for arc measures.
But
Ooh, reverse engineer. I like that.
we were thinking that like.
Tell me, sorry to interrupt, tell me specifically what central angle you're talking about. Show me.
If you have to connect 80
You're gonna go 80 to that whole angle there. So if you can find that angle, you can find the arc measure.
Yeah.
Good, find that angle. I was giving Joe the, hold on a second. I was just flipping along. Okay, so you don't know how to find that angle, so you plane pliers. But if you don't remember how to find that angle, can you find another central angle? That's all you get.
Wait guys, okay, if we think about this is not a sausage triangle. And but it's not a sausage triangle. You know this is 20, you know this, and you know this. So this and this thing work congruent because this is also 12
Yeah.
72 degrees.
But I don't want to do yeah, and then they'll time it back to. Yeah, well, wouldn't it be 180? Wait, would it be 180 minus 90 divided by 2?
No, they're not equal because it would be the same intent.
You know, the 30 side measures, we know all these side measures in that triangle. Okay, here, so you do, you know, you would have to, yeah, then you would have to do sine of 90, but you're not like, you can't do
Can we just do a sign?
we don't know any other, measurement, like any other degree in the triangle. Tangents opposite, not tangents.
Next year we'll move that. Point?
No, wait, yeah,
Clever, and it did not work. That's not
Very capable. All right, so what is your...
And you get 1 time.
Wait, no, I think they, that's for this one.
Wait, how'd you do that?
No pressure, man. No
Oh, there it is. Okay, I didn't see that.
Yeah, and then
All right, to remind you.
A is approximately
There's a triangle. It's a right triangle.
He's probably gonna say, I don't know.
I mean, it seems about right. I'm gonna use a different one than A because we already have a different
Okay, so let's come back together here. I know some groups got it, some groups didn't. There are, I saw at least 2 or 3 different methods. I saw 2 methods and then somebody suggested a third. So let's talk about all the different ways that we can answer the bonus question. Okay, so first method I saw is, are we all good on the 12.2?
Yeah.
Okay, good. First method I saw is somebody found angle B. Okay. Now you might be saying to yourself, Self, why would you find angle B? It's the exact question I asked, but as they progressed through their explanation, it made sense. So they set up the law of sines. Sine of angle B over 7 is equal to the sine of 90 over 12.2. Blah, 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 blah. B turns out to be 34.99, 35 degrees. Which is of no use except for one small fact. This chunk of information will get us this angle. And why do we need that angle? Yeah. This angle will give us this arc. And most groups were able to answer this question. What's the relationship between these 2 arcs? They're equal. Because again, if the chord is cut in half, it's also going to cut the arc in half. This is a 90-degree angle, and all of a sudden this angle turns out to be 55. So this arc is 55, this arc is 55, and we get 110. Good? Okay, that's method number 1. Method number 2. Just some plain old straight up right triangle trig. The tangent of angle, let's call this angle alpha. Angle alpha is equal to 10 over 7. Blah, blah, blah. Alpha equals 55, and we proceed from there. Okay? Now, I know you guys did that, right? Straight right triangle trig. What did you guys do? Law of sines. Okay, you could also do law of sines for this same triangle. I'm guessing you did sine of alpha over 10 equals sine of 90 over 12.2? Beautiful. However, another group suggested a third method, which I talked them out of because it's ugly. But let's get rid of all this stuff and go back to where we started. Okay, we know that this is 10, this is 10, this is 12.2, and this is 12.2. Ideally, I'd like to find that angle. Let's call it beta. If I know that angle, then I know the arc directly, correct? How could I solve for angle beta here? Your idea. It was your idea, yeah. Do you not remember it being your idea?
Oh, splitting the thing in half?
No.
No?
No, what was the first idea you came up with and I said, that's too ugly?
Oh, using like law of sine to figure out like that angle with that whole triangle, like
No, that's the other method.
cosine?
Yeah, law of cosines, okay? This is a law of cosines problem, and I think you all agree that nobody likes to do law of cosines, right? 20 squared is equal to 12.2 squared plus 12.2 squared minus 2 times 12.2 times 12.2 times the cosine of beta. I think you would all agree that law of sines and right triangle trick is easier, yes?
Yes.
But there's 3 methods to all solve the same problem. A lot of you started by saying, oh, well, wait a second, that arc's got to be 180. It's not. When is it 180? Yeah, when it's a diameter, that's the only time. Okay, make sense? Problems? Beautiful. Then, for the rest of the period, I'd like you to do 3 things. Go over day 1 with your group. If you have any questions, ask. I'm here. Either ask your group, ask me. Number 2, go over day 2 with your group. Submit both of those when you're done, and then day 3 is for homework for tonight. Okay?
Day 2 we did together, so we didn't have to go over that.